The wire when you go.
What kind of contact on a wiring schematic is this?
That's a
That is
open
a switch.
It could be a type of switch. This would be considered a normally open.
Oh.
You're gonna often see NO on the somewhere on a contact that looks
Jaime
like
said
this.
that.
This would be
Normally closed.
Oh, now
NC.
you
You got that. You got that one too. Jaime got it again.
Yeah, you took this past before, huh?
Let's see.
Did you have this class? You got that one?
Yeah, been here.
This would be a transistor.
No, that's a switch leg.
Oh.
Oh,
What's this one?
That's
It's a little bit bigger.
That's a low
bigger
pressure
not.
switch.
Let's see. Bigger's not giving it away. That's
This is going to be one of those black things that you have over there on your
Black
on the
thing.
board. It's called a limit switch.
Yeah, limit switch.
So this is a limit switch,
What'd you say, Jaime?
and it has
I got something.
just
Jaime got
the
it.
same thing as those ones over there. It has a common screw. It has a normally closed, and then it has a normally open.
Oh, okay. That's like a proximity switch or whatever they call it. I guess. Okay, I got
Ones we
it.
have.
It has a roller on there. I see.
Yeah, that's exactly what those
Okay.
are. So, with normally open and normally closed contacts, if you take a relay and you're holding it in your hands, it's going to show, and you look at it, it's going to say normally open, normally closed on it. And it'll have like maybe even a drawing on it. When it's de-energized and in your hand, normally, if it says normally open, then that means that contact is open. And if you see normally closed, then that means that contact is closed. If it's in your hand, de-energized. Once you apply energy to that, you're going to change this to, this is going to be closed and this is going to be open. So whenever you're working on something that you're messing with terminals, if the coil is energized, every relay, Ruben, can you pull one of those relays out, those ice cube relays out of that device there? Just a relay out.
Yeah, very time.
Thank you. So this little relay has a coil inside. You can see it, the white coil in there. I'll pass this around in a moment. And when this gets energized by the wiring is on the back here. It says that this is 2 and 7. Once 2 and 7, the 2 and 7 pin get energized, it's going to energize that coil. It's going to open a solenoid, or it's going to move a solenoid, and it's going to change all the contacts in here, which you can see on this little drawing. That normally open becomes normally closed, and normally closed becomes normally open becomes closed, and normally closed becomes open. So I'll pass this around so you guys can take a look at that.
What did you say, 2 and 7?
On that one,
That
it's
was
2 and 7.
That was to
It's,
energize the
8
coil.
The pin numbers.
That's
Energize the coil.
an 8-pin relay, and on that 8-pin relay, 2 of the pins are connected to the coil inside the relay. And then the rest of them are just contacts for you to wire as you see fit. So we have normally open, we have normally closed, we have common, we have a normally closed contact with our switch, and we have a normally open contact. Here we have, what is this?
No pressure.
Hey man, that's a female anatomy.
Looks like the ovaries.
Oh boy.
This is a float switch, and you see like the ball on the bottom of the switch. This is a float switch. It's a normally closed float switch. So if you guys see this, and you guys have float switches here, so like what we were talking about yesterday. You guys have float switches here. So this would be a normally closed float switch, and then a normally open float switch would be like this. So how would we use these? If the water level, and I'll use green water, if the water level gets up to here, it's going to make the float go up just like in a toilet bowl, and this contact's going to open. Same thing with this, once the water level gets up to here, It's gonna make this flow go up, the contact is gonna close, and now we're gonna have continuity on our circuit. So before I go on, because I've used a term that I haven't used so far, continuity. Do you guys know what continuity means? Continuity means essentially that it's kind of like I'm saying I'm testing the same wire. I have a direct connection from one to the other. I have continuity. So we can check for continuity on a tester. It's got all of them have like all multimeters have a setting where you can check for your resistance, and then it might have a separate setting that you can check for your continuity with a sound. So you can just check it with a. That means I have continuity, and I hear this.
What's that in?
That's gonna be the ohms symbol. I'll pass this around, and it's got the kind of like the speaker. This also has an intensity setting. I kind of talked about that before. When I'm checking my wire, if I have my float switch here closed, and I have current traveling through this conductor, I'm going to be able to see that when I have this changed to A. Now, some battery systems, you can check your DC amps, and some battery systems you can't. Your UPS system over here, I cannot check amps on this one. With this tester, you have to use a special tester to do that. But on some BBS systems I can. This one has a voltage setting that does AC and DC. So if I plug this into the wall,
Oh, it doesn't care which one it is, huh?
if I plug this into the wall, it tells me it's AC and it's 119 volts, and it gives me the green, or it gives me the red light there.
Maybe it works.
I could also hold it. So now maybe I'm in a spot I can't read. I can't read this. My meter's down here, but I could get my finger on that button. And I can pull this out. Oh, it was 119. That's what that's for. Now it's kind of nice to say that we can decide if this is going to be AC or DC, but sometimes that could be a bad thing.
Oh,
Huh?
it's a bad thing. How?
Sometimes it's a bad thing.
I
So
want to know this.
if you're not familiar with traffic signals use low voltage where the pedestrians come into contact with the traffic signal. So you have a push button at the pole so you can cross the street. I mean, you guys have all seen these cross the street at some point in your lives. You push that push button. Well, we don't want to put 120 volts on that push button. We put those push buttons at 15 to 18 volts. Those push buttons are DC voltage, 15 to 18 volts. So that way, in case it fails, you only have 15 or 18 volts, which is pretty safe. You can touch that, you can probably put that in your mouth, and it wouldn't shock you at all. So if it's bad to be able to check for DC and AC voltage because of another thing we haven't talked about, inductance. Are you guys familiar with inductance?
He remembers it from being inducted in the military. Is that what you were saying?
Wrong one.
Wrong one.
Same thing though, you were both up.
Here we go. This is an inductance tester. You guys have all seen these?
Yeah.
You guys have one? So how does it
Yeah, I
work?
have it.
Tell me how it works.
Put it in the plug.
Same thing with the
You put it in the plug. Not doing
You
it.
touch wires, whatever.
So this is my neutral, the one here with my neutral. If I put it here in the positive one, it should work. I could if I think this is hot, but I want to make sure because I just checked my it's not working. I can always check it on my arm, my pant leg. The nicer tick tracer that you buy, the sooner it's going to break on you. This one is an extremely cheap version. Doesn't have any flashlight or special buttons on it. It just has you just push this thing here. It's very cheap. It's almost garbage, but I've had it for about 15 years now, and it still works.
See what I've been telling you? See what I've been telling you? They're making fun of my damn,
I told you to throw yours away a long time ago.
making fun of my thing. It works
So
every
this is an
time.
induction tester.
Except
It
on
doesn't
12
say, it doesn't, it can't tell me that there's voltage here, it tells me that there's inductance here. Like I said, alternating current goes up and down and creates a magnetic field. And when it creates a magnetic field, it induces current. And this can pick up that induced current. So if you have a conductor, let's say here we have a panel board and we have wires going out, maybe they're 500 feet. We got 2 wires going out there. This one is live and this one is dead. In fact, I could even disconnect it here. If I use this tick tracer and I test it on this wire, it's gonna say that's live.
It's gonna pick up the other one?
It's gonna pick up the other one on this one because this live conductor is inducing on this conductor that's not live. So
Good tip.
what if I'm using my voltage meter and it picks for me AC or DC and I'm testing that dead wire to ground? I could get 15 volts. I could get 18 volts. I've seen up to 30. But you have to be real tricky because it'll say AC, and if I'm checking a DC circuit, which I don't always look for, I just look for the number. But it will tell you whether it's AC or DC. If you have DC, it'll say, hey, I got DC voltage. If you don't have DC and you have AC inductance, it'll say AC. One tester that never gives you a false call.
Yeah. Clink, clink, clink.
This is called a wiggy. Actually, it's labeled wiggy. Now this will check DC and it'll check AC, but it has a solenoid just like the relay did that got passed around. This has a plunger that physically moves, so you have to have real energy. When you have induced energy, and we call this ghost voltage, because although you might be able to test for it, it can't do anything. You can't energize anything. You can't make a light come on.
You just plug it to the outlet, it'll show you 120.
This, I
240.
plug it in, and it changes the plunger to 120. This one here I just used it, but this one here is not legal to use because it does not have a category listing on it. All testers should have a category listing on it. They do have wiggies now that are category listed. I'll pass this around.
We need a wiggy. We need some wiggies, man.
So this fluke tester, which is in my opinion superior to that, does have a category listing. It's dual listed, category 3 and category 4. So what does that mean? Going from one subject to the next very quickly. Here is the meter, and here is our branch circuit. Here's a sub panel. Here's the receptacle. So a class 2 receptacle or a class 2 meter can only check here. A class 3 meter can check from here, all of this up to the meter. And a class 4 meter can check in front of the meter section. So if we have a class 4 meter, we can do everything. If we have a 3, we can only do up to here. And if we have a 2, we're only doing this. So that one shouldn't be doing anything. So this is really a much better one to have. It's dual rated though. It says Cat 3 at 1,000 volts. So if this is a 1,000 volt circuit, I can go only up to category 3 for this tester. If it's a 600 volt or less circuit, I can go all the way up to category 4, which means I can go before the service. So essentially this does everything I need it to do. Let's see, what else about this? If you don't know, you can go like this and test a little easier, so you can have a free hand.
Show us how to arc the probes.
Yeah, this one's been chipped, burnt up a little bit. What is this? Oh, this actually has a category rating too. It says 3 in category 3.
Let me probe you.
Okay, so I'm gonna jump from that to this. Let's just continue on with meters.
Put a strap on it.
So fluke meters are generally thought of as the industry gold standard. They're like, not necessarily, I wouldn't call them the Cadillac, but they are certainly the top of the game. They're the highest quality meters and the highest rated meters that are out there that we use. You guys know what this is, right? What's this?
Tells you if you messed up your blood.
It's a plug tester.
Polarity.
So I can plug this in. This tells me,
got
it
the
can't
wires,
tell me
is
the
that right?
polarity. It can tell me that it's divided correctly. Ground fault. Some of them will have the ground button. This one doesn't. This receptacle is wired correctly. Some of them have a ground button that you can test. If this receptacle was protected by a GFCI and I wanted to know whether it was or not, and it had a button on here, I'd plug it in, push the button, and I should trip a GFCI somewhere. All of your receptacles in your kitchen or outside or in your bathroom should be GFCI protected. If you lost power somewhere in one of those locations, I would be thinking GFCI problem. It tripped somewhere.
Tribute.
This is essentially the same thing that's being passed around out there, except it has a different test lead.
Clamp on.
It has a clamp. It has a clamp meter on it, as opposed to just the forks. This one will use larger size conductors than that one. I took this one out to the batteries yesterday to see if it would work. It does not work on the batteries because the power's too clean. But this is a good tester. It will do larger conductors than those ones. Those ones it sometimes can be a pain because it doesn't do bigger wires. This is an ideal. There's essentially the same thing as that one or this one, but ideal aren't as accurate. They're not as
They're not as expensive either. They're pretty.
I'm sorry.
They're cheaper. It has benefits. It still has a hold button. It has this NCB
I like the hold
button,
the
which
whole button.
I'm not sure what that does.
Do they have that in Harbor Freight? Is that?
Don't buy hardware break.
That's where I got mine, the little box one.
This one is an X-Tech. These can be expensive, but they're still, I prefer the Fluke. You got 4 options on this thing. You got continuity, you got amps and volts. You're not gonna screw that up. And you got off, of course.
It's just
And
the
if you
name
don't
Fluke.
turn it off, it'll turn itself off after a while. This one here is, it's a decent meter as well. It's more accurate for testing voltages that are lower. Like if I have low 0.3 volts or 0.3 amps and I put amp leads on here, I'll be able to check this more accurately than I can this one. This one also has a cool feature on it. It has an infrared setting. It makes an annoying noise, but I can do infrared and Fahrenheit. According to this wall is 75 degrees.
Oh, built-in thermometer, nice. Yeah.
It shoots out a laser to determine what the temperature is. I don't know where that laser is unless I push this button. So I can push this button and I can check the temperature or something. This is 74 degrees. How is this helpful for you? Well, sometimes you're going to open up a panel, you're going to have problems. You want to know if it's a live panel. I don't want to go in there periodically, take my screwdriver and tighten up all the screws because I'm going to have to gear up. That could be potentially dangerous. I could cause a problem. I could put a temperature sensor on all of my screws and see if the screw's hot, then I know that it has a poor connection or it's using a lot of current. This one is a toner. So
You put
this
a